Hey folks, today we are going to go through the system design interview. Imagine in the interview, you are given 10 minutes to build a user interactive server. What would you do? Now, the first rule of system interview is always take the question back if the requirement is too vague. The most important thing is collaboration because apparently you cannot build the system just by yourself. So they may want to just build the system with you or help you to build your system. So you can always come up with this skeleton system design over here. Especially when it comes to focusing on the user, how user interacts with the web server. There are 4 basic steps you must understand from this design. The first one is that the user requests to visit the website. It will send the request to DNS. The DNS is called the domain name system. It regulates all the IPs and it will send back with the IP address that associate with the website. The IP address then used to communicate with the server because the server cannot understand the website's name. They can only communicate through the IP address. The web server receives the IP address. It will return back the HTML page to the user. The HTML page is the front-end language for the user interactive layout. And there are differences of the response between the web browser and the mobile app. Usually the HTML page is for the web browser. For the application on the mobile, it usually has the JSON response which is well formatted. Now, if you are interviewing with the jobs such as backend engineer or data engineer, most likely you will focus on the database part. There is one fundamental concept you must understand that relates to the database. Is that the difference between the relational and non-relational database? The relational database, which is more traditional, we have, for example, MySQL, Postgres, and Oracle. However, in the modern big data industry, the non-relational database becomes more and more crucial because it can handle and restore large amount of data. For example, we have Neo4j and Dynamo database. Only the relational database can perform the joining operation, where it can emphasize the relationship between one table and the other table. It is also good for building the report for analytic purpose. On the other hand, the non-relational database cannot perform the joining operation. It is more suitable for the applications such as data warehouse, and it has the flexibility to support different types of data such as the key value, the graph data, and the documents. If you are getting more and more traffic, it's time to think about the scaling. You can perform the vertical scaling on the individual server by simply increasing the performance of the GPU or CPU. Or we can do the horizontal scaling by adding more and more servers. Since we are now having multiple servers, it's time to introduce the load balancers so that we can handle more than one server. The load balancer can distribute the traffic evenly. For example, we can distribute 50% to the server 1, 50% to the server 2. If the server 1 goes down, the load balancer can balance the 50% to 100% and direct all the traffic to server 2. In terms of the downstream of web servers, we need to deal with the database. Think about the use case that most of the users are only just watching YouTube videos or reading the blogs. So they actually perform the read operations on the replication of the database instead of touching the master database. If the master database goes down, you can actually promote one of the slave database to be the master database that enhance the reliability and high availability. If the users are interested and frequently reading one category, such as the sports, instead of storing the sports into the database, you can actually store it into the cache, and the cache can simply mitigate latency and the workflow of reading the database. This is also a good practice to have multiple cache based on the amount of the database. This can prevent one point of failure. However, the cache is not good enough to reduce the latency based on the geographic. Think about the use case that the users are currently on the East Coast and they want to interact the data on the West Coast. Especially interacting with the static object such as the videos and images that are not easy to store in the database. We can introduce the content delivery network that usually running by the third-party provider. It can help us to retrieve the static information such as the image and present to the users. We can also have the CDN that is on the middle of the West and East Coast on here. This can reduce the latency. So the users, instead of interacting with the database itself, is actually the content delivery network provide the images to the users. While the users are interacting with the servers, there are 2 types of architecture, stateful and stateless. The users can get the faster response from the stateful architecture because the server remembers the session data from the users. For example, every time you log in into your user account, it always interacts with the same server. But it is very challenging to handle the failure if the server 1 goes down. It is difficult to migrate the user A data to the server 2. Therefore, we introduce the stateless architecture that the users are sharing the web service. The stateless architecture is more robust and scalable. Let's say your application continues to grow and you need to move your database to next level, which is the data centers. In the data center, we integrate the web services, the databases, and the caches into one individual data center. Let's say the DC2 US West, this data center goes down. The load balancer will distribute the traffic to be 100% to the other data center, which is replicate from the DC2. Although in this approach, you can pull your data into a safe route, it is very challenging that you need to make sure the data sync between those two data centers, which is very costly. We have 2 steps left in order to build a good design for millions of users. Let's say your applications requires a third party's workers. It is very common. For example, if your data requires modeling or training, you need to borrow the other application servers in order to train your data. Let's introduce the message queue, where it temporarily stored the data that we received from the producers. It will later be consumed by the consumers. Let's say the message queue are storing multiple actions. If the producer goes down or the consumer goes down, we are still having the historical logs in the message queue. So it creates the buffer for async communications that we can always look back to restoring the data. A sophisticated application also requires appropriate logging. It creates the monitoring page that monitor if there is an incident happens in production. If it has, it automates create a ticket to the support team. There is another way that we can evenly distribute the traffic goes into the databases. It is called the shared databases. For example, we can hash the user's ID, that we can distribute the data horizontally into different databases. However, because of the replication among these databases, it is hard to perform the join. So at some point, if you are running some analytic reports, you need to denormalizing this database into one. And this concludes our chapter 1 that we can scale from 0 to millions of users. If you like this channel, please click like and subscribe. Thank you.